Part 1. Intro, Dream or Illusion? Look closely at Earth. This floating blue marble is our only home. The entire history of humanity, every empire that ever rose and fell, every brilliant scientific discovery, every war, every terror, and absolutely everyone you've ever known or loved, existed right here on this tiny speck suspended in the infinite dark. But the history of the universe teaches us one very harsh and unforgiving lesson. Species that choose to remain on a single planet will eventually disappear. Whether it is an asteroid impact, extreme climate shifts, or our own doing, the cosmic clock is always ticking. That is exactly why right now, in the humid, swampy landscape of South Texas, a new and unprecedented chapter of human evolution is being aggressively written. In a facility known as Starbase, SpaceX and its founder Elon Musk are working day and night to build Starship. This is not just another rocket. It is the largest, most complex, and most powerful flying machine in the entirety of human history. But the ultimate goal of this towering steel giant isn't just to plant a flag on another dusty rock and quickly come home to take photos. The ambition is far greater, and to some, much crazier. The mission is to build an autonomous, fully self-sustaining megacity on the surface of Mars, capable of supporting 1 million people. Today, we are going to break this monumental plan down to the atomic level. We will explore the transportation logistics, the brutal economics, and the terrifying biological risks. Buckle up. We are going to Mars. Part 2. Transport, the End of Expendable Rockets. To truly understand the sheer, mind-bending scale of the Mars colonization plan, you first have to realize the biggest fundamental problem in the history of spaceflight: single-use rockets. For decades, humanity flew to space using a completely unsustainable business model. It was exactly as if you bought a multi-million-dollar Boeing 747 for a single flight from New York to London, and immediately after landing, you just dumped the entire airplane into the freezing ocean. This expendable approach made space an incredibly expensive luxury reserved only for elite government agencies. Starship is the holy grail of space exploration because it completely shatters this paradigm. It is a fully and rapidly reusable transportation system. Both the massive first stage booster, known as Super Heavy, and the upper stage Starship itself are designed to return to Earth. They are meant to land perfectly back on their launch pad, be inspected, refueled, and fly again in just a matter of hours, much like commercial aircraft. Furthermore, the rocket is constructed from highly durable stainless steel, a material that is incredibly cheap, easy to weld, and capable of withstanding the scorching heat of atmospheric re-entry. But a journey to Mars is no quick trip. It takes anywhere from 6 to 9 months traversing the dangerous void of deep space. To deliver the massive amount of heavy cargo required to build a city, Starship simply cannot take off from Earth and head straight for the red planet. It would run out of propellant. It absolutely requires orbital refueling. Imagine this breathtaking sci-fi scenario playing out in real life. A massive ship enters low Earth orbit, nearly empty of fuel. Immediately, several specialized tanker rockets launch right after it. They physically dock with the main ship while traveling at 17,000 miles per hour, transferring hundreds of tons of super-chilled liquid methane and oxygen directly in the vacuum of space. Only when the tanks are completely full does the Starship ignite its engines to break free from Earth's gravity and begin the long coast to Mars. Part 3. Economy, Logistics of a Martian Megacity. The key to building anything on another planet is logistics, and historically, delivering just one single ton of cargo to the surface of Mars using traditional rovers cost billions of dollars. Elon Musk's ultimate goal is to completely crash that delivery cost to roughly $100 million for a massive payload of over 100 tons. In the context of aerospace economics, this is an unprecedented, physics-defying drop in price. How is this even remotely possible? The answer lies in relentless mass production and the strict laws of orbital mechanics. Earth and Mars do not stay at a constant distance. They only align perfectly for a fuel-efficient journey once every 26 months. During this brief window, known as a transit opportunity, SpaceX plans to launch not just 1 or 2 ships, but an entire armada. A literal star fleet of hundreds, eventually thousands, of starships will launch to Mars simultaneously. The very first waves of these ships will not carry humans. They will be uncrewed cargo vessels carrying advanced, autonomous robots. These robotic precursors will have one crucial job: to scour the Martian surface, mine massive deposits of subsurface water ice, and set up a sprawling chemical plant. You see, the Raptor engines that power Starship run on a specific mixture of liquid methane and liquid oxygen. By combining the mined Martian water with carbon dioxide pulled directly from the thin Martian atmosphere, we can use the Sabatier reaction to synthesize rocket fuel right there on the red planet. This is the most critical pillar of the entire plan. The ships must be able to refuel on Mars in order to return to Earth. If we cannot manufacture fuel locally, the Martian city will quickly run out of supplies and turn into the most expensive and tragic graveyard in human history. Once the fuel factories are running, the real construction begins. Starships will deliver massive solar panel farms spanning miles across the dusty landscape. Giant autonomous rovers will dig foundations and deploy heavy-duty glass and steel domes. These habitats will need to be equipped with closed-loop life support systems, capable of recycling every drop of water and every breath of air. The logistics of this Martian megacity will require Earth to act as a relentless supply chain for decades, pumping millions of tons of steel, food, and machinery across the solar system until Mars can finally mine and forge its own materials to become truly self-sufficient. Part 4. Survival, Biology and Psychology. We all love to stare at those highly polished, beautiful architectural renders of massive glass domes filled with lush green trees, cascading waterfalls, and people wearing light jackets while looking at the Martian mountains. But the brutal reality of the first century on Mars will be a harsh, claustrophobic survival scenario taking place deep underground. The red planet actively wants to kill you. The very first and most invisible problem is radiation. Mars has lost almost all of its atmosphere, and it lacks the global magnetic field that protects Earth. This means the surface is constantly bombarded by highly destructive galactic cosmic rays. Furthermore, without a magnetic shield, any major solar flare erupting from the sun could deliver a lethal dose of radiation in a matter of hours. To survive this, the first colonies cannot be built on the surface. We will have to seek shelter deep inside ancient, natural lava tubes, or we will have to use heavy robotic machinery to bury our habitat modules under several meters of dense Martian regolith to create an artificial radiation shield. The second major problem is gravity. The gravitational pull on Mars is only 38% of what we experience here on Earth. We are fundamentally children of Earth. Our entire biology, our cardiovascular systems, and our skeletal structures are perfectly adapted to 1G. In the low gravity of Mars, human bodies will begin to degrade. Muscles will rapidly atrophy from lack of resistance. Bone cells will slow down, meaning our bones will lose density and become as brittle as porcelain. Can a human body adapt to this over a lifetime? Can a human safely carry a child to term in partial gravity? And will that child grow up healthy? Modern science simply does not have the answers yet. But perhaps the most terrifying and underestimated enemy is the human mind itself. Try to truly imagine the psychological toll. You are living in a cramped, artificially lit bunker that constantly smells of recycled air, ozone, and machine oil. You will never again feel the warm breeze on your face, swim in a natural ocean, or walk in a forest after the rain. Earth is no longer a world. It is just a dim, insignificant blue star in the dark night sky. And because of the vast distance, radio signals take up to 24 minutes just to travel one way. A simple real-time video call with your family back home is physically impossible. It is a profound, crushing level of isolation unlike anything humanity has ever faced. Part 5. Conclusion: a one-way ticket. When confronted with these monumental challenges, the obvious question arises: why do we need all of this? Why should we spend billions of dollars, exhaust massive resources, and risk human lives in the cold void of space when we have so many unsolved problems right here on Earth? The answer is as simple as it is profound: the long-term survival of consciousness. We have the technology to become the very first species in the history of this planet to consciously make ourselves multiplanetary. A self-sustaining city on Mars is, in essence, our ultimate backup drive. It is a biological insurance policy guaranteeing that the fragile spark of human consciousness will not be completely extinguished in the event of a global catastrophe, be it an asteroid impact, extreme planetary shifts, or our own technological missteps. The path to the red planet will undoubtedly be paved through fiery explosions on test pads, colossal financial gambles, and inevitably, the tragic loss of early pioneers. But that is the heavy price we must pay for a permanent step into eternity. So, take a moment and imagine that right now, a boarding pass for Starship is lying on the table in front of you. The flight reads, Earth to Mars. The return date is left completely blank. Knowing the massive risks, the severe isolation, and the incredibly harsh reality of the mission, would you dare to pick up the pen and sign your name? Let me know your honest answer down in the comments below. If this video made you think about our future, hit the like button and subscribe to the channel for more deep dives into space exploration. The cosmos is closer than it seems. See you in orbit.